The cosmic journey. The universe, it is believed, began with the Big Bang, and it's a mystery of how it happened. All that is known is that it came to be in this way. So much occurred in the first second of creation that scientists were forced to dissect it to put everything into perspective, and in so doing they created a new conception of time that they named Planck time. There are a billion Planck times in 1 second compared to a billion seconds in the universe's history so far. Before the dawn of creation, the universe was pure energy, and it was in an infinitesimal amount of space. Then somehow it exploded. When the universe began, it was in state of perfection, and there was a single super force that ruled everything within creation. Its perfection was shattered into non-perfection when the super force was somehow split. Suddenly, gravity broke away from the super force, and it had just the right strength to create the universe that we have come to know. If it was weaker, it would have sped away too fast, and the galaxies would have not come into fruition, and if it were stronger, the universe would consist of only black holes, and we would not be here to contemplate its origins. In 10 million Planck times after the Big Bang, the universe changed from a super hot dense ball of radiation to expand much quicker, and its temperature dropped, and the strong nuclear force materialized, and ironically that without it, the atoms would fall apart and disintegrate. After that, the expansion of the universe got much bigger for the briefest moment of time. In less than a millionth of a millionth of a millionth of a millionth of a second, the universe expanded bigger than a million times, and was faster than the speed of light. It expanded from the size of an atom to the size of a tennis ball, and as it did, it turned chaos into order, spreading the constituents of our universe evenly throughout space, and fixing their positions within it. Today the universe is nothing like the early universe, for it was hot, chaotic and full of energy. There were no stars, galaxies, or even atoms. And because matter is concentrated energy, and they could transform into each other. Transform they did, so the energy turned into matter in 1 microsecond after the Big Bang, but it was not like the matter that we have today. You had a primal universe that was made out of quarks that created a perfect fluid liquid of elemental particles. As the universe expanded, it cooled. And when the heat of the universe dropped to 2 trillion degrees, the strong nuclear force clumped the quarks together in groups of 3s, creating protons and neutrons, which are the building blocks of atoms, but the matter had no mass, just elementary particles fizzing around at the speed of light. The Higgs field that permeates the whole universe, accompanied by the Higgs boson particle, interacted with the particles, giving them their mass by slowing them down as they pass through the field. As particles passed through the field, they created more mass. Without the field and particle, there would be no mass, atoms, and universe, as we now know it. Then, still within the first second, the weak nuclear binding force and the electromagnetic force came into fruition. After that, they came together with the other 2 forces, and the 4 forces that now existed drove the evolution, or the cosmic development of the universe. It is believed that a series of Higgs bosons are the reason of why the super force lost its symmetry, and split into the 4 cosmic forces that we have today, giving us the stars, galaxies, planets, and life. The universe was an inferno of radiation and matter, but the 4 forces had been created, so the universe had begun. However, before our universe began to take hold, there was the battle between matter and antimatter, of which the early universe was made out of, and because they could not coexist together in the same universe without exploding, when they met they nearly cancelled each other out of existence. However, because matter had 1 in a billion more particles than antimatter, when the universe was nearly a second old, it was victorious, and matter survived, and the residue from that battle is what our current-day universe is constructed out of. The universe within the space of just 3 minutes went from the Big Bang to the forming of hydrogen, helium and lithium, from a universe that was infinitely small to a universe that was light years in size and extremely hot. Then everything spread out and cooled for about 380,000 years. Then electromagnetism came to be. The protons and electrons began to slow down. And then they began to feel the electric forces as they combined together as atoms. And that transformed the foggy universe that was a dark vast milky soup full of excited electrons and protons hurtling through a sea of high-energy photons into a visible universe, and they began mass-producing atoms with the residue that was left over from the aftermath of the Big Bang. There were slight variations of temperature as some areas were hotter and others cooler, and these variations in temperature showed the differences between having more or less matter. The former would become empty space, the latter the construction sites of stars, planets, moons and galaxies, and it was the blueprint of our present universe. The hydrogen came together to form enormous clouds, and the magnetic fields grew stronger, as the atoms whirled around each other. Then they aligned and they generated vast highways of strong magnetic fields, as they grew into all the magnetic fields that the universe has today. 280 million years later, gravity began to attract hydrogen clouds towards its center to go on to form stars. However, angular momentum, which is the force that stops the moon from falling into the earth, stopped the gas from falling into the star's center, preventing the forming stars from reaching critical mass, stopping ignition. The charged particles produced magnetic fields when they moved, and the swirling gas and the spinning stars were powerful enough with the fields that they generated that they slowed down the gas cloud, and gravity was the victor. The cloud was drawn towards the forming of the stars, and ignition happened. So 12 billion years ago the first stars were born, and then the universe had warmth and light. The first stars were huge, hot and powerful, and they consumed vast amounts of material, so because of this they did not have a very long lifespan, only few hundred million years. When they became exhausted, the explosion that followed created new stars to exist in the universe. Some of the mass from the giant stars was so great that when they collapsed they were too heavy to create the next generation of stars, as they tore through the universe's fabric to form supermassive black holes. These supermassive black holes drew together their neighboring stars toward their center with their gravity and electromagnetism, which helped form and shape the stars into the primal galaxies, and they still do the same even to this day. The stars in the galaxies, with the aid of gravity, consumed their hydrogen, and when the stars ran out of hydrogen they began to die and were hotter. After that, they started to expand, and they became many hundreds of times larger, and it was then that they began to cool to become red giants. While there was still enough hydrogen to burn, the stars were in a stable condition, but when it began to run out with the force of gravity they began to collapse in on themselves once more, leaving an outer layer of hydrogen and helium behind in their wake. Beneath the shell the cores collapsed, heated up, and the helium nuclei started to fuse together, forming carbon and oxygen. The helium stopped the stars collapsing for a while, but when the helium ran out, the stars were compressed again and carbon fused together, forming sodium, magnesium, neon, and aluminium. As the stars carried on collapsing they went through many stages, and each of them were hotter and shorter than the ones that preceded them, which consequently created more elements that were forged within their hearts. In the final stage their hearts turned into a solid ball, and the elements were stacked on top of each other in layers. The layers then fused into solid iron, and they had but a second to exist. When the stars ran out of fuel they imploded, creating 26 of the common elements that we have today. After that they folded in on themselves at a great speed. And then they suddenly rebounded with a colossal force. And when they expanded to the outer layer of the stars, they reached 100 billion degrees, lasting just 15 seconds. In this extreme heat, the heavier elements were created, which exploded into supernovas, scattering their remains into space, and as they exploded outwards they formed nebulas, and the gravity began to create new stars, for it is in the deaths of old stars that the next generation of stars are born afresh. The collapsing stars also left behind neutron stars in their wake. And as two binary neutron stars spiraled around each other, they moved closer together, tearing each other apart. Then they combined in a lethal union where they exploded, creating the biggest explosion since the Big Bang, and it was there where the extreme temperature was reached that was needed to create the rarer, heavier elements such as gold, iridium, uranium, and lead. Just one more element existed that was not created out of collapsing stars, supernovas, or the deaths of binary neutron stars. They were created by cosmic rays that were ejected from supernovas, like laser guns, as they shot across the universe, smashing atoms apart to form lithium. Lithium was also created at the beginning of the universe, along with other lighter elements, and they were also created in stars, but it was only temporary, as they could not stand the extreme heat, so they blinked out of existence. It was 4.6 billion years ago that the next step in creation came into fruition that formed our Sun, which was a third or fourth generation star that gathered up 99.9% of all the gas and dust that was in its sphere of influence, and the remainder of the gas and dust, sculptured by gravity, went on to form the 8 planets that made up our solar system, of which Earth was just one. 4.5 billion years ago, a planet called Theia crashed into the Earth, and its core and mantle mixed with ours, leading to an increase in the Earth's core and mantle, which had been a mystery because the Earth had a larger size than normal for the size of the planet. Theia's debris eventually became our moon, and its water helped fill our oceans, and the Earth stopped wobbling, and developed a tilt, and the Earth gained its current stability. Theia's gravity and the debris eventually became our moon, which slowed down the rotation of the Earth from 6 hours to 24 hours a day. And with the tilt, which gave birth to our seasons, it paved the way for life to evolve. So 3.5 billion years ago, heat, nutrients, and hydrothermal vents on the ocean's floor were the catalyst for life and evolution. At first, 3.5 billion years ago, there were just microbes, and some of them used photosynthesis to survive, and others survived by extracting nourishment from their environment, and they went on to form colonies, and after that, microbes existed like that for 3 billion years. However, the oxygen that was released with the photosynthesis poisoned the air, and loads of them died, but some evolved to breathe the oxygen, and they were able to survive. Next, the Earth cooled down, then the surface froze because of the oxygen, which lasted for millions of years, and life nearly became extinct, though some did survive, as they adapted to the environment. Afterwards, Earth's temperature rose, making it more favorable for life to flourish, and because there was a global surge of volcanic eruptions pumping carbon dioxide into the air, melting snowball Earth with the greenhouse effect, we had a new progress of life on Earth. As the ice melted, the nutrient-rich water flooded into the oceans, which the microbes used as a potent, rich fertilizer that helped them to multiply. They began to stick together, forming multi-celled organisms that could collect more food. They did this as they pumped out vast amounts of oxygen with photosynthesis into the atmosphere, and it was with the use of that increased oxygen that the cells produced collagen, which stuck them together as a team, and they were able to harmonize with their environment. 570 million years ago, they were no longer just clumps of cells. They became more sophisticated, larger, and they were organized into more definitive shapes. They found an easy way to construct their bodies, It was in a fractal nature, each branch growing out from their predecessor. They were too deep on the ocean's floor to feed on sunlight, and they were not able to move, so with their branches they fed on dissolved carbon and other nutrients from the water, which they passed through their bodies. Unfortunately, they eventually became extinct because they were incapable of evolving like other animals did that the future was to bring. 550 million years ago, new animals emerged that had mobility, but they still lacked any hard parts to their bodies. They were like cushion-type creatures that lived on the ocean's floor, and they ranged from the size of a penny to the size of an average-sized bath mat. They absorbed organic material that was beneath them, and their movement was very slow. Then more animals started moving, and this gave them a great advantage as danger could be avoided, richer sources of food were had, and they could move away from overcolonization unlike the animals before that were fixed on the ocean's floor. They had almost identical halves. If you split them down the middle, they had a head at one end with a snout, a tail at the other, and probably a singular muscular foot, which helped them to move along the seabed to get food. They developed a front end, grew eyes, feelers, and at the back end they developed a pore to excrete waste. They had segments between the head and tail, then by adding more segments they grew larger, and in the middle on their appendages hooks and claws developed to move and catch things to set the mold for future animals. In order to keep up with the ever-changing environment they had to reproduce differently because animals up to that point simply divided to reproduce, but that was not efficient enough. Then, 350 million years ago they evolved by exchanging genetic material with sexual reproduction. Their gene-swapping techniques meant they were able to adapt to their ever-changing environments from one generation to the next, and add variation to the genetic pack by creating differences in the gene pool and helping nature by speeding up evolution. 550 million years ago the mobile animals began to move faster. And they developed a new way of eating because they had to get large amounts of energy to move quickly, and as they were slow at absorbing nutrients, they developed mouths, teeth, stomachs and anuses to become predators. It was then that everything became truly productive with evolution's Big Bang, or the Cambrian explosion, which some believe were where eyes came into the mix, where predators and prey could see each other, and this brought on an evolutionary arms race that led to the development of all life that did, or currently populates our planet, humans being just one branch on that tree of life. chicken or the egg? Scientists do not know what came first, the galaxies, or the black holes, the former being the aforementioned Big Bang theory, and the latter being the supermassive black hole theory that I will explain below. But in order to explain, I must begin again with the universe's origins. In the infant universe, out of the Big Bang first came dark matter, which is invisible matter, and then the dark matter began to clump together because of gravity. Next, the clumps attracted the matter, they became so dense that they created supermassive black holes, and they tore through the fabric of the universe. The supermassive black holes consumed all that was about them, including each other, making them even more massive. They were, and still are, messy eaters, and they emitted mass from their accretion belts as they ate, and when it spewed out and hit the gas in the universe, it caused the gas to clump together, making new stars. The new stars were drawn together by gravity at the black hole center, and with the electromagnetic fields they formed galaxies. It was billions of years of destructive chaos in a crazy violent cosmic dance that continued over and over as the bigger galaxy kept eating up the smaller galaxies and objects that surrounded it. As they collided, they stripped mass from each other, smashed together, merged, and it was because the galaxy was bigger, or more dominant, that it survived, that then became an even bigger galaxy, and this cosmic consumption still goes on today. There are 200 billion stars in our galaxy, and hundreds of billions of galaxies in the universe that formed and continue to be formed in this way. Ironically, the supermassive black hole that is at the center of our galaxy, that is 2 to 3 million times the mass of our Sun, that created the new stars at the beginning of our Milky Way, is now limiting new stars from being created today. Basically, only one star in our galaxy is being born each year. The answer was revealed when a lit-up disk of gas and dust was seen spinning around the supermassive black hole at the center of our galaxy from a modern-day telescope called New Star. As this material was swirling around in the disk, it heated up with friction, making it 100 million degrees Celsius, which is 18,000 times hotter than our Sun, and it appears that this superheated gas is harmful to star formation. In order for new stars to be born, the gas has to get cold, so as it can become dense enough to form nuclear fusion at its core. So, the area around the black hole is so hot that it heats up the gas around it, and this limits the ability for the gas to form new stars. Further, mass amounts of energy emitted from the black hole not only destroy stars, but blows away the gas that form new stars, thus they become the creators and destructors of stars in the galaxy. The merry-go-round. I am sat upon a chair. In a room. In a building. In a street. In a town, in a county, in a country, on a continent, upon the world that spins once a day at 18.5 miles per second, traveling at over 1,000 miles per hour, and it is traveling through space at 540 miles per hour as it goes about its annual solar orbit. The Sun orbits the Pleiades once every 25,000 years. The Pleiades orbits the center of the Milky Way once every 225 million years, that is traveling at a speed of 370 kilometers per second through space and time. Earth is 25,000 light-years from the center of the Milky Way and 25,000 light-years from its rim. There are 100 to 200 billion stars in the Milky Way, which is just one galaxy in an infinite expanding ocean of galaxies that exist within the universe, that is constantly speeding up because of the effect of dark energy. The cosmic cake. The ingredients of the cake are quarks, electrons, the strong nuclear, the weak nuclear, the electromagnetic, the God particle, and the gravitational forces. 3 quarks bound together with the strong nuclear binding force form either protons or neutrons. If you take some protons and neutrons and bind them together with the weak nuclear binding force, you have a nucleus, or the center of the atom. The proton is positively charged, and the neutron is neutral. Both the nucleus and the electrons shoot out short bursts of photons, and the polemically charged particles absorb each other's light that draws them together, and the force is known as electromagnetism. The number of protons within the nucleus is always equal to the number of electrons in the shell of the atom. The more complex the nucleus, the more complex the atom and the diversity of its atomic structure. Electromagnetism also binds atoms together, which is how molecules, of which our bodies and everything within the whole universe, or reality, is made up of, or exists. Then, we have the Higgs field, and the Higgs boson subatomic particle, and they are one of the fundamental building blocks of the universe. They give the universe by slowing down super-speeding particles their mass. Finally, the one thing about general relativity is that everything floats in straight lines, and also drops into, or orbits the troughs of warped space and time that gravity creates. The larger, or heavier the object, the greater the cosmic force. The universe is a vast fabric of both space/time, and the gravity of celestial objects create the peaks and troughs in that fabric, from the tiniest specks of dust to the largest stars to even speeding beams of light. Their gravity influences and sculptures the universe. The moon is orbiting, or dropping into the trough that is created by the gravity of our Earth, and the Earth is doing the same with our Sun. Likewise, our Sun, and all our other celestial bodies in our galaxy are orbiting, or dropping into the trough created by the gravity of a supermassive black hole, which is at the center of our galaxy that is believed to be 4 million times more massive than our Sun. The Milky Way is orbiting, or dropping into the troughs created by the gravity of other neighboring galaxies, and it is believed that our galaxy, the Milky Way, is going to collide with our neighboring galaxy Andromeda within the next 3 billion years, or so. The strongest force of gravity known to humankind has got to be the gravity of a black hole. Early black holes are believed to have been the creators of the galaxies in our universe. We think that black holes can be as small as a single atom, or a billion times greater than our Sun. Further, it is postulated that they are infinitely deep, and some are thought to have been created from the final stage of a dying star that were 15 times the mass of our Sun. The center of a black hole is still a mystery to humankind because nobody truly knows what lays hidden in its depths. Black holes are the creators and slayers of all the galaxies. The nature of time. Time seems from the common-sense realist view to travel from A to B to C and on to Z in a chronological linear fashion. Yesterday leads to today, and then tomorrow will follow today. The past becomes the present, then eventually it's tomorrow. Even one's words, sentences, and actions are governed by time as we communicate with each other. Some state that we observe time from the present, and declare that because of this there is only the now. They suggest that we look back at our pasts and that we look forward into our future, which creates an illusion of time. It takes 8.5 minutes for the light of our Sun to reach us, and 13.8 billion years for the furthest galaxy ever seen, called GNZ11, that came into being just 4 million years after the Big Bang to reach us. So when we gaze into the heavens, we are gazing into the past. Further, when objects reach the event horizon of a black hole, they are near the speed of light at their entry, and time slows down. This clearly shows that we are surrounded by illusions. Others propose that it is the limitation of our senses as it filters through our sensory data that creates the time illusion. Everything within our universe is connected to time, and that everything that time governs has a birth, generation, maturity, old age, and a death. As we observe nature and its natural cycles from our planet, we have found a way to calculate, objectify, and utilize time extremely efficiently. The world rotates upon its axis, and each rotation is a day. Our planet is caught up within an orbit around the Sun, and one full cycle is 1 calendar year, which we dissect into seasons, calendar months and days. The phases of our moon reflects the polar opposites as we systematically divide them into 4 quarters that make up one lunar month, or 28 days. We dissect time further and they become nanoseconds, seconds, minutes, hours, days, months, seasons, years, centuries, millennia, a googolplex, and then forever onward into infinity. I'd like to add that, if our planet, or the orbit of our sun were larger, that we would have a longer day for the former and year for the latter. I thought that I would just mention that, just to reiterate that these are our calculations applied to our solar system's natural cycles and size, and they fall within the ethos of general relativity. When time is utilized, we can objectify our plans. For example, I will meet you on the 3rd day of the week at 1600 hours in July. Alternatively, one can book a holiday in the summer sun in whatever year one chooses. Although one cannot guarantee the weather, for we tend to gamble by applying one's reason against the chaotic and random seasons, as we ski in the winter, ramble in spring and autumn, and populate the beaches, and ultimately to bask and swim in the summer sun. In recent times, the chaotic weather patterns are even more askew as the effects of global warming kicks in, so we have got to either pull up our socks and get our acts together, or change the way that we all live. Let us now venture forth into the paradoxes of our understanding of time, where it has been suggested that time has been speeding up since the 1980s. What was once a 24-hour day is now thought to be approximately 16 hours. Scientists discovered some years back that the Earth gives off a pulse. This pulse, or frequency, that has been likened to a heartbeat has been stable at approximately 7.8 cycles per second for thousands of years. Scientists go on to say that the pulse will reach a critical mass, and the Earth will stop rotating altogether when it reaches 13 cycles per second. It's estimated that it will stop for approximately 3 days, and when it begins again it will rotate in the opposite direction, reversing the magnetic fields. As it does so, what happens to the Earth after that is unknown. We have known for some time the paradox of the watched kettle that takes its time to boil unless left unattended, and if an examiner sits in the same room as the examinees, time is different for all of them. The examiner's time is long and drawn out as he watches over his class, making sure that they don't cheat, or if anyone is in need of a new pen. The students' time flies by as they desperately try to complete their exam before the bell, clearly showing us our subjective contradictions of time. In short, time seems to travel faster when we are having fun, or participating in positive, or positively constructive agendas, whereas time slows down when we are participating in negative, boring, or routine agendas. In October 1971, Joseph C. Haffel, a physicist, and Richard E. Keating, an astronomer, tested Einstein's theory of relativity when they took 4 cesium-beam atomic clocks aboard commercial airliners in what has been called the Haffel-Keating experiment. Basically, they flew twice around the world, first to the east, and then to the west, and then they compared their clocks against others that had remained back at the airbase, which was called the United States Naval Observatory. When they reunited, the 3 sets of clocks were found to disagree with one another, displaying different times, and their differences were consistent with Einstein's predictions of special and general relativity. On the whole, the test demonstrated the prediction that clocks should run at different rates in different places of a gravitational field. Further, there have been experiments where 2 atomic clocks have been placed on board 2 jet planes. And one plane traveled at its peak above the sound barrier and the other plane traveled below the sound barrier, and when the clocks were placed together at the end of the experiment, the one that traveled on the plane above the sound barrier appeared to lose time when compared to the other that traveled below the barrier. Finally, when observing the behavior of subatomic particles in particle accelerators, the subatomic particles have a slower decay rate, so it seems that when subatomic particles travel at greater speeds, time slows down. Essentially, time dilation says that as we move through space, that time is measured differently for the moving and the unmoving object. Basically, time slows down the nearer that one gets to the speed of light. Out of the fields. Contrary to particle physics with all its confusing facts, it is suggested that space is made up of oscillation, gradients, or vibrations of quantum fields that are filling space. Particles are observable, unlike the quantum fields that cannot be seen with the naked eye. Empty space is simply when the quantum fields are in their quantum ground state, and it is when these fields interact that particles are created and we can see things happening in our universe. They theorize that everything in the universe is an excitation from these interactions, whereas previously it was thought that particles and perceptible fields were originating from different sources. Every particle has a field from which it is from. An electron is an excitation of an electron field, the proton from a proton field, etc., like waves in an ocean, and this kind of thinking eradicates the confusing facts that come with particle physics. A quantum field can be realized mathematically, however, to actually witness a perceptible field, they can be felt when two magnets come close together. They can also be observed when you place a magnet under a glass sheet. Tip some iron filings on the surface of the sheet, then the magnetic force passes from beneath and on up through the glass to its surface, and the iron filings, instead of falling into a pile on the sheet's surface, they form a three-dimensional pattern, displaying the field from the magnet below. They can also be witnessed with the universe's gravitational and the Earth's magnetic fields, so it is then that these same kinds of fields are what the universe is really made up of. When particles decay, we think of it as shooting out different kinds of particles. Neutrons decay into protons, electrons to neutrinos, etc. Even though protons, electrons, and neutrinos appear to come out of neutrons, they are not hiding inside ready to pop out, even though it appears that they do so when the neutrons decay. Further, if you create a particle in a large hadrons collider like the one in Switzerland, it will be identical to the same kind of particle that was forged millions of years ago within a star, creating an anomaly of why are they the same with so much space and time between them. On the whole, when we think in terms of quantum fields, it begins to make sense. No. They are not inside the protons, hiding ready to leap out. What is really happening is the excitation of a field. So, the energetic protons are vibrating together, transferring their energy to the fields that are next to them, and in so doing they form excitations that we see as the new particle as it comes out of the quantum field into our observational universe. The Higgs effect. The Higgs boson particles that are the latest to be discovered are the only particles not to make sense, because you have matter particles and force particles. Essentially, they are created as scientists smash protons together in the Large Hadrons Colliders, and this being made possible has turned theory into fact as it gives substance to the hypothesis particle. Going with the field theory, however, the Higgs boson particles is not giving all the particles their mass by gluing them together in clumps as some scientists suggest. The Higgs boson field is everywhere in the universe, accompanied by the Higgs boson particle, which the field continuously uses to interact with other particles. As the massless particles travel through the field, they are given mass via the Higgs boson particles, which contain mass in the form of energy, and the massless particles slow down and become heavier. The field's existence gives the particles mass, and if the mass was not there to attract one another, gravity would not exist either. Light gains energy as it passes through the field because it is a wave, and not a particle, the Higgs boson field is the reason of why the universe has its appearance, and without it the universe and life as we know it would not exist. The microscopic universe. Imagine a world where you could pass information faster than the speed of light over vast distances. Pass through solid objects. Where you could travel backwards in time and change the past. Where you could be in multiple places at one time, pass through solid objects, or where you could be invisible, or where there could be a creative ingredient that affects our world by creating parallel universes. Well, imagine no more, as it can all be found in quantum physics with their experiments from the microscopic world. Scientists have reached the conclusion that to understand our universe that we must understand the universe within first. When people talk about the universe, they talk about stars, galaxies, planets, and the laws of nature, but to understand the quantum world is essential if we want to know where everything comes from. In this place trillions of times smaller than the visible cosmos, the laws of nature do not exist, and scientists have developed a new science to make sense to what is actually going on in the subatomic world. Quantum entanglement is where a particle that is in one place can affect another particle in another place even if it is millions of miles away. How it works is that when two particles become entangled they spin and form a link connecting the two. How they do this is still a mystery. If a scientist influences or changes the spin of one of the particles, the other one immediately changes its spin. And stars to spin in the opposite direction, even if it is light years apart, suggesting that the particle has broken the speed of light barrier as it passes information instantaneously across the universe to its entangled partner. It seems that consciousness affects the behavior of the quantum world, thus demonstrated in the double light experiment, where the light is projected from one source as a particle, and then it becomes a wave as it passes through two holes at the same time to end up on a screen. How the particles become a wave is open to debate, but it seems that when they are being observed that they remain as particles, and when they are not they become waves, and this is called the quantum enigma. The scientists proclaim that when consciousness observes the subatomic world it has a major influence on the particles that are being observed. Which leads to the question of why doesn't it merely change the direction of the particles? Why is it that it actually changes the nature of what is actually being observed? The answer, no one knows. It is just when they are looking they are particles, and when they are not they are waves. With modern technology, scientists are now able to delay their decision to observe the particles after they have passed through the holes, but before they hit the screen, and it seems when they do this that the waves that pass through the holes become electrons once more. Somehow the observation of the experiment has had an influence upon them, and they appear to travel backwards in time and change their past. It all sounds like science fiction, but could reality be nothing other than the figment of our imagination? When scientists tried to unravel or measure the subatomic world, they found that they could not perform the task. They suggested that there is not a fault with the measuring process, it's as if nature itself does not know, and this, which is the most profound concept to come out of the microscopic universe, is called the uncertainty principle. In a nutshell, they simply cannot know anything with absolute certainty. In the subatomic world, scientists cannot determine where anything is positioned because of their wave-like qualities, and if they try to box in a particle, it always generates enough energy to break out of it before its position, speed, and energy could be determined. When an electron is bounced off a wall with a small amount of energy, sometimes they bounce back like a standard tennis ball, and sometimes they pass right through, in what is called quantum tunneling. It is suggested that they borrow energy from the future, and pay it back when they reach the other side. They suggest that the electron is on both sides of the wall, and it merely appears to go through it to reach the other side, thus being in two places at the same time, and as we are made of electrons that we ourselves could be in two places at once, and that every time we reach a decision we do not choose one over another, we in fact do them both in slightly different versions of reality. They suggest that we could in fact be in many places at the same time, each reaching a different conclusion to our decision. Quantum mechanics suggests that every time we observe something that you become two different copies of yourself, which they call parallel universes. As if that was not enough, you have dark matter, which holds a gravitational influence over matter, and it cannot be seen even though it makes up 85% of the gravitationally attractive stuff in our universe. Without dark matter there would be no structure to the universe, and there would be no galaxies, planets, or life. It turns out that most of the matter in the microscopic universe is not made out of protons, neutrons and electrons. It is theorized that dark matter must have an unknown particle left over from the Big Bang when the universe was very hot, dense, and it was in its youth. And they suggest that the reason why it cannot be detected is because it is not something else, but somewhere else, and that it could be in other higher dimensions. Or it could simply be that the particles that make up dark matter are so small that they are beyond human detection, which takes us to what is the smallest particle in the universe, and the scientists have surmised that it is not a particle at all. In fact, they propose that all particles are made up of tiny strings of energy, known as string theory. String theory proclaims that particles are made up of quarks, and that they are made up of strings of energy, or membranes, and they also suggest that all the four cosmic forces can come together with the theory. Scientists hope that this theory does what they suggest, which tells how classic physics and quantum physics come together in what they call the unified field theory. On the whole, the microscopic universe governs everything in our universe, thus solving one of the current mysteries of the modern age with the theory of everything. They say that, if you imagine a box with a musician inside playing the cello, that on the outside of the box it would be seen as many different notes, but if you took off the lid of the box you could see that they were all coming from the same strings. In much the same way, this is how we see the universe with its stars, galaxies, planets, and the four cosmic forces, whereas in the subatomic world they are all coming from the same strings. In effect, they say that the different notes of the strings create different things like an electron, a proton, gravity, or light, and it is the law that is governing these strings, which is the harmony of the strings, that are the laws of physics. They also state that according to their hypotheses that there must be 11 dimensions, 7, which are invisible to the naked eye because they are too small to see. However, if you were able to decrease to a millionth of a billionth of your current size, you could see them. Further, they state that, if the cello player can play a seemingly infinite amount of different songs, that each song could be a different parallel universe. Scientists suggest that our whole universe could be on a single membrane in a higher dimension of space that is within the microscopic world, and that we could be one universe of many, in what they call the multiverse, or parallel universes. These membranes, or brains, move in extra dimensions of space, and they say that sometimes these brains collide, and this could be the answer to how the Big Bang originated and expanded with the energy from the collision, so the Big Bang may not be alone, it could be one of many. The Mandela Effect. Many people remember many things that did not in fact exist. People remember Nelson Mandela dying in prison when in fact he died after he was released, and this is where it was first brought to the world's attention, hence, the Mandela Effect. Others remembered Kit Kat having a dash, when in fact it never had one, and was spelled just Kit Kat. Others recall Luke's father from Star Wars saying, "Luke, I am your father," when he actually said, "No, I am your father." Others remember Captain Kirk saying in Star Trek, "Beam me up, Scotty," when that was never said either, and finally people remember the logo of the man on the Monopoly board having a monocle when he doesn't. Most people put this all down to mismemories, but then why? Or how do so many people have the same mismemories even though they have never met each other, or had human contact? Some say that this is proof that parallel universes exist, and that they sometimes collide. So are we remembering facts and things from these parallel worlds as they collide? Perhaps, we are holding on to the memories of them when they separate. They propose that the parallel universes would have different properties. Some could be similar to ours, and could have stars, galaxies, planets, and life, and others would not. The paradigm shift. It was once believed that the universe was slowing down from the effect of the Big Bang, and that the gravitational forces would eventually suck it back in on itself into what has been called the Big Crunch. However, recent studies suggest that the universe is in fact speeding up, and it has brought with it a paradigm shift that has been broken down into 5 sequences. The first stage is the dawn of creation, which is said to have been 13.82 billion years ago. Then there is the present, which is followed by the third stage where the stars and planets become extinct with nature's natural destructive progression. The fourth is when the black holes run down and blink out of existence, leaving us with the final stage, which is a sea of light particles and/or photons, which are said to travel through time as they chaotically wink in and out of existence. That's all the physics covered, but it does leave one wondering of whether this reality has all happened out of chance and chaos, and that we have just accidentally arrived here with evolution, or was it God? Science would suggest that the parallel universe theory answers this question with that our universe is but one universe within an infinite amount of universes, and with a series of random chaotic chance events in each. Life had a high probability of existence without a God, although some modern-day scientists proclaim that we are all connected to God. Science and spirituality. I was watching a lecture today on science and spirituality, and the lecturer opened up by saying that space is not empty. It is full of energy that comes to the surface from the electromagnetic fields from the base of all reality in what is called the quantum vacuum fluctuations. Basically, there are fluctuations in this vacuum that create and organize our physical reality. The universe is an extension and also part of this vacuum in a holographic universe. Apparently, scientists can now extract protons from the vacuum in controlled experiments in the lab with superconductors in what they call the dynamical Casimir effect. They believe that the universe talks with itself as it creates, the point being it's self-conscious. With scientific and Eastern spiritual hypotheses, they suggested that the base of reality is God, and then they questioned what is God. The universe is self-aware, and it is viewing itself from within different points of space/time. Fundamentally, everybody sees things from their own perspective, but because everything is interconnected in one, there is a mass consciousness observing itself of which we are part and parcel, and why not call it God? The spiritual quantum. Spiritual quantum physicists suggest that the universe is both alive, intelligent, and it's dreaming the universe into existence, and that through meditation, our heart chakras and DNA, that we are able to connect to it. They suggest that we are biochemical computers that are fragments of God, and when we were children our purity resonated with our Creator with no blockages. They say as we grow up we are polluted with negative energy, obstructions, or human-computer viruses that cut us off from connecting to the source. This could also be put down to what we believe is what we perceive, so if we don't believe in God we won't connect to it. However, if we unblock the pathways, or gain an awareness of God, we are able to reunite with our innate power within, tune in like aerials, and this brings back our spiritual connection. Then we can retrieve our innate power, which is our union with God. Apparently, we can unblock our natural energies with yoga or qigong. We at the same time must connect to self-love. That being to look after ourselves and take pleasure of what we love to do, not fall in love with our reflection, and let's not forget to love our soul mates, family, friends, and to bring forth, harness and utilize the many other forms of love that is within our destiny. Let us look now to philosophy to see their view on the external world. For instance, are we seeing reality, or is it all an illusion, including the self, God, and our part within creation?